Almost everybody has snail fever. The doctor whispered in my ear.
Okay, let's get this show on the road. Okay, so welcome back. We'll be talking about Chapter 4 of the textbook in this lecture today, and Chapter 4 deals with psychological measurement. So we've already spoken a little bit about this in previous lectures, and you've come across some of the concepts that we're going to be talking about today in some of the previous readings that you've done. But we're going to go into much more detail about psychological measurement, the concept of error that exists when we do try to measure variables, and issues relating to reliability and validity, things like that. Okay, so starting off, when we talk about variables, if you remember from 221, hopefully, that a variable is just anything that can vary, that can change. And if we're talking about a scale that we're measuring something on, it's a variable because it can take on a different value of that scale. So if it's a, say, independent variable, something that we are going to manipulate, it's variable because it can change. We can decide which level, let's say, of that variable people will be assigned to, and how many levels of that variable there'll actually be. So variables are, say, the opposite of constants. Constants don't change at all. So in psychology, we often deal with what are known as hypothetical constructs. We don't deal with variables or concepts even that are very easily measured. Instead, we're dealing with things like, say, happiness, right? Or depression or love. How exactly do we measure these types of things? There are no blood tests for happiness, right? You can't put somebody on a scale and find out how much depression they have. So we tend to measure these constructs, these hypothetical constructs, and we can think of these as attributes or mechanisms that for us can help explain or predict human behavior. The problem is that oftentimes they're not directly observable, so we have to find ways to measure these types of things. Remember, we're psychologists, so a lot of the things that we're interested in are not even behaviors. Behaviors, at least we can observe. Sometimes we're interested in people's cognitions or their emotions, and those are not always observable, let alone measurable or easily measurable. However, these types of cognitions or behaviors, behaviors are much easier to observe, but these cognitions or emotions can often be associated with something that can be measured. So we can measure these hypothetical constructs indirectly. That doesn't mean that we can't, or that we shouldn't have a very precise and objective definition of how we're going to measure these things. We absolutely should, but we're going to have to measure something like love indirectly, right? There's no love tests that we know of, right? Not yet, anyway. So we need to come up with a conceptual definition, also known as an operational definition. But when we talk about a conceptual definition, this is our attempt to state the meaning of this hypothetical construct. We'll see an operational definition is, well, how exactly then do we take this conceptual definition and measure it, right? What are the operations that are going to be involved? So an operational definition, we'll see in a minute, goes one step further. But we'll take this hypothetical definition and this hypothetical construct rather, create a conceptual definition as an attempt to state what we mean by this hypothetical construct. And when we see these conceptual definitions, these are kind of like the definitions that we might read in a textbook. So an example here, well, a few examples here for aggression. What is aggression? Well, it's kind of a hypothetical construct, but people can define it in different ways. And then even if you're on the same page when it comes to how you're defining it from a conceptual definition point of view, people might actually measure it in different ways. That's where that operational definition can vary as well. But so something like aggression, we see one definition, conceptual definition of aggression, as a response intended to inflict pain or discomfort. Another one, any form of behavior directed toward the goal of harming or injuring another living being who is motivated to avoid such treatment. I'm blocking this third definition here, so bear with me. The use of threat or force in territory not clearly one's own, without clear evidence that a majority of the emotionally involved people in that territory want such intervention. Ooh, that's a mouthful, right? So there's lots of conceptual definitions to something like aggression, and you're going to find the same type of variation in definition. Some are going to be more straightforward, some are going to be more involved. We could see this first one here, response intended to inflict pain or discomfort, is focused more on the motivation behind the person doing a particular action. This last one here, this third one, seems to be more of a sociological type of approach. It seems more like a war type of definition of aggression, or some type of intergroup conflict type of definition there. So we can take these hypothetical constructs and define them, conceptualize them in different ways. Then, once we have our conceptual definition, we have to come up with a plan of how we're actually going to measure these things, right? So this is where the operational definition comes in. So with the operational definition, we can think of this as a description or a plan of how that conceptual variable is going to be measured. So an example of this, let's say for aggression, we said we're going to take that hypothetical construct, we're going to conceptualize it as a response intended to inflict pain or discomfort. But what exactly does that mean, right? There are a couple of components of this definition here that raise some questions that we're going to have to answer, and that's what the goal of the operational definition is going to try to do. Let's try to answer some of these questions. So first, what constitutes a response? Before I said behavior, but maybe what kind of behavior? Does it have to be physical behavior? Can it be a verbal behavior? Does it have to be a behavior necessarily? Can be a look or even an aggressive thought, right? So an emotion or cognition. We have to determine. We have to lay out what do we mean by a response. Also, how are we going to determine intention? How are we going to determine what the person intended? That's often really difficult to do. This is why usually you have jurors, entire trials that that are there to determine someone's intention. The easiest way to determine intention is to simply ask someone what they intended to do. But an act that appears to be aggressive, or an act that does inflict pain or discomfort, might be intentional, right? But it might not necessarily be bad. If you think about someone accidentally nails their hand to a piece of wood or something, and you want to help them get the nail out of their hand, you're going to respond in such a way to pull that nail out, and it's going to inflict pain and discomfort, no doubt, on the person who's got the nail in their hand. But is it your intention to inflict pain or discomfort, or is it your intention to get the nail out, to help them? And the pain and the discomfort is not intentional, but it's let's say a byproduct of your response. All questions in terms of getting to what exactly is the intent of the person. Sometimes we will inflict pain and discomfort on people without intending to do so. Also, what do we mean by pain? Does it have to be physical pain? Does it have to be emotional, psychological pain? Is there some type of severity in terms of pain? If a friend flicks your ear or something like that, it's as a joke. Are they acting aggressively? It might sting for a second or cause discomfort for a second. Was it their intention to inflict pain or discomfort? Probably, as like a little joke type of thing. Is it necessarily aggressive, right? Is it aggression? What about like love bites or love smacks, right, on the butt of a partner or something like that? It's not necessarily the intention to inflict pain, but it is. But the intention might be to show interest or to be playful or whatever. So as we keep going through this idea of aggression, you can think of, okay, what's going to constitute a response? What's going to constitute intention? What constitutes pain, right? Does it have to, like we said before, be physical? Can it be emotional or psychological? Does it have to have some threshold? What if it's just very mild type of discomfort? So the same definition there goes with the same issue or question goes with this definition of discomfort. What exactly do we mean by this? So there's lots of unanswered questions that come with this conceptual definition, and the operational definition is what's going to help us outline exactly what we mean when by this conceptual definition. So the operational definition has to be stated. Essentially, it's how are we planning on measuring this definition? So just as a recap, we often, in psychology particularly, right, we study a bunch of things that are not easily measurable. So we have to take these hypothetical constructs that exist out there, like happiness or aggression or love or what have you, and we have to conceptualize them. We have to create a definition about what we mean for them. In our study, what do we mean by it? And then from that conceptual definition, we have to create an operational definition, which basically says, this is how we're going to measure it. So when we come up with this conceptual variable, our operational definition, or this conceptual definition, our operational definition is, and this is exactly what we mean by that conceptual definition, and this is how we're going to measure this conceptual variable here. Okay, so hopefully that all makes sense in that regard. I guess the rest of this lecture basically tells us how we can make good measurements of our variables, how we could be sure that we're really measuring what we say that we're measuring, right? That our operational definition really is a way to measure that conceptual definition, and that conceptual definition is really measuring that hypothetical construct. So it's all about being reliable, being valid, being accurate in terms of how we are measuring things. Okay, so when we talk about defining variables, or how we might measure variables, let's say we have a research statement that says exercise leads to weight loss. That might not even just be a research statement. That's a testable hypothesis right there, right? We can test this to see if it's true. And if you're familiar with research in this area, exercise definitely can help with weight loss, but it's really reduction of calories that is the most important. Exercise is great for the heart, definitely helps with weight loss in terms of building up metabolism, building up muscles and whatnot, but let's not get off track, right? So this, let's say, is a testable hypothesis. Exercise leads to weight loss. Okay, what do we mean by exercise? That's number one, something that we have to think about. What constitutes exercise? Do we have to go to the gym? And if so, how long do we have to be at the gym? How many days a week do we have to go to the gym? What do we have to do when we're at the gym? Right? Does walking up and down the block count? Does walking dogs count? Does doing household work count? What exactly is exercise? So we'll have to define that. A couple ways that we could define it is 10 push-ups each day, right? That might not do a whole lot, but it's a good starting point, right? And we could test, does just doing 10 push-ups each day lead to any type of weight loss? Now we haven't gotten to the rest of this definition here, or the statement. We have to also define what we mean by weight loss, but we'll get to that in a minute here. And even the word leads, this idea of causation, is something that we're going to have to be concerned about, to make sure that if we're going to make a statement that exercise leads or causes weight loss, we have to clearly define what we mean by exercise, clearly define what we mean by weight loss, and we have to be really careful that it is in fact the exercise causing the weight loss and not something else, which we'll get to later on in this chapter. Okay, so some other examples: we could define exercise as walking 3,000 steps each day, and we might be able to measure that with the pedometer, right, or your Fitbit or something. Or we could define it as 30 minutes of aerobic activity 5 days a week where heart rate is greater than 140 beats per minute, and that could be measured by using a heart rate monitor and a stopwatch, right? So the way that we measure exercise, or the way that we're really defining exercise here, again, can get increasingly more complicated, and sometimes the more complicated we get, the more equipment we might need in order to actually measure some of these things. Okay, we also have to think about what do we mean by weight loss, because we know that muscle actually weighs more than fat. So if we're just interested in losing fat or weight in terms of fat, but we want to gain muscle, we might not notice any reduction in actual weight, right? Because we're losing fat but putting on muscle. So how do we want to define this? Again, a couple of ways that we can do it. The first is by just the number of pounds that a person has lost, and this can be done by a scale. Again, that depending on what the goal here is, that may or may not be useful for us. Another way to look at weight loss is to look at the waist size, right? So the size of the belly, essentially, especially in men. So males will typically carry most of our extra weight in our guts. Unfortunately, this is where beer bellies and whiskey bellies come from. And females will carry most of their extra weight either in the hips and in the bust type of area. So, but let's just say, in this case, waist size, we can measure this with just a measuring tape to see if there's a reduction in waist size or any size, or any part of the body, the size of any part of the body. We could start getting a little bit more sophisticated here and measure weight loss in terms of body fat content, right? Or your body fat ratio. And this involves a mathematical type of measurement. Or we could measure weight loss in terms of how well people's existing clothing, is fitting, or the size of their clothes. Are they dropping in clothing size? And this could be done through a survey, just by asking people how their clothes are fitting, or by observing, how well each different size of clothing is fitting a person in terms of how it fits their body, if it's too baggy or too tight or just right, so to speak. Now, it would be a good idea, because not all of these we can see have their own problems here. Pounds lost doesn't account for muscles gained. Waist size is only measuring one type of, let's say, weight loss, just belly fat in this case for waist size. The body fat content might not account for, say, changes or redistribution of fat in the body. If somebody wanted to add some heft to their backside, let's say, but wanted to slim down on the waist, that might not be picked up here, right? The body fat content would likely stay the same. And of course, when it comes to clothing fit and size, different manufacturers, we all know this, right? Go try to find a pair of jeans in your size. It really all depends on the brand. So 30 or a 32 waist is not going to be the same across all jean makers, for instance. So it might be good to have multiple measures of weight loss. So we measure weight loss in multiple ways. Maybe a combination of all of these things, or maybe all of these things plus more, right? Maybe there's some other measures that we're not even thinking of right here. So this idea of converging evidence, having multiple points, multiple measures of, let's say, in this case, this is our dependent variable, because this is what we are measuring. It might be good to have multiple ways of measuring this, and thus creating convergent evidence. It'll be more convincing. So if someone says, I lost 5 pounds in 1 week of dieting, again, those who are familiar with nutrition and dieting knows that that's likely water weight that comes off in the first week, and that's why it kind of sucks. You get really excited that first week. It's like 4 or 5 pounds are gone, and then it's 1 or 2 pounds every week. After that, sometimes no pounds after that. So you're like, what the hell? So kind of tricks you. You're like, shit, 4 or 5 pounds a week. I'm gonna be in that bathing suit, right? If the beach is ever open, in no time. But no, that's not exactly how it works. So, the more measured outcomes that we have, it increases the chance that we're really measuring that part of the construct that is most relevant, is most interesting to us, that we really care about. In this case, weight loss, right? So another way that we can say restate this research statement or hypotheses is by saying that exercise leads to lower scale weight, smaller waist size, and reduced body fat, right? That's a much stronger and more convincing hypothesis and more convincing statement than exercise leads to weight loss, right? We still run into the problem here about what do we mean by exercise. But that would be defined if you were doing a study on this, you would have to define that as well. Okay? So what makes for a good operational definition? Well, it should definitely be specific, meaning your measurement should be detailed enough that other researchers should be able to replicate your study using the same operations, using the same measurements, the same steps that you took to measure your variable of interest. Someone reading your study should be able to replicate it 100%. So operational definition should be specific. It should be reliable, meaning that your measurements should produce consistent results. This is another thing when it comes to measurement that we're going to see in a minute here, is that there's no perfect measurement of anything. So a reliable measure there'll be a tolerance, or what we call a margin of error. So we want to keep that margin low because we want our results to be reliable. Every time you step on the scale, we want it to give the same result, or every time we measure someone's waist, we want it to be the same, or anytime we calculate their body fat content, we want it to produce the same results, all within a margin of error, an acceptable margin of error, right? And an operational definition should be valid, meaning that we should actually be measuring what we are claiming to measure. So one thing that a lot of people, particularly when it comes to measuring the waist, a lot of people don't really know where the waist is. A lot of people will measure kind of around their hips, especially since most pants, most jeans now sit a little bit lower. It's not in the 70s or 80s, and we don't wear jeans up to up to our chests anymore. But the waist is actually right above the belly button, like almost right at the tip of the belly button there. That's the actual waist. The gut, especially for beer bellies and stuff, your waist is actually a little bit above that. People will tend to either, measure around the widest part of their belly, or actually measure their hips. So we just know that from taking a look. If you ever get clothes fitted or tailored or anything, watch where the seamstress or the tailor is actually measuring you. You're like, oh wait, that's where you're supposed to measure. Okay, right. So we might not even be that would not be a valid measurement if we were measuring people's hips, when our definition said we were measuring their waists, right? So a valid measure is going to be measuring what we claim to be measuring. So how should we measure this stuff? There's lots of different ways, right? The first is self-reports. And particularly in, say, psychology, when we're dealing with a lot of variables that pertain to how people feel on the inside, or those inner mental processes that are going on, their cognitions, their emotions, their motivations. Sometimes this is the most accurate way to measure those things. It's just by asking people, what did you mean by that, right? Or how are you feeling right now? We can certainly use behavioral measures. We can take a look at a person and see that they're crying and use that as a measurement of sadness. The only problem is people also cry when they're happy, right? Or when they're scared, or when they're excited, or when they're angry, or when they're nervous. So crying isn't so good of a measure, right, of someone's emotions, because we tend to display the same type of physiological arousals that we do for multiple emotions. So even measuring somebody's heart rate to determine if they're nervous, well, our heart rate goes up when we're excited as well. And excitement and nervousness, not exactly the same thing. Excitement tends to be associated more with positive feelings. Nervousness associated more with negative feelings, even though it's kind of producing the same physiological response. So when it comes to, I skipped ahead a little bit there, but these physiological measures, they could certainly be useful, but when we try to use them to tap into some of these more hypothetical constructs, say like love, if you haven't experienced romantic love yet, you will one day, hopefully, if you so choose or so desire, but you get kind of that jittery type of feeling. Your heart starts fluttering a little bit. And if we relied solely on, say, oh, okay, so the heart is starting to race when this person walks in the room, they must be into that person. They must really dig that person. Well, what if you really hated that person and you wanted to, smack them in the mouth or something? Your heart rate might go up as well. So that might not be a good measure for some of these hypothetical type of constructs that we often do study in psychology. But let me just get back to the list here, jumping ahead a little. So self-reports, these are basically just asking people about their behaviors, about their cognitions, about their affect, their emotions, or their motivations. And self-reports can be done through a survey or a questionnaire, or they can be done through an interview. So they could be done by asking people verbally. We could also measure these different types of variables through tests. And tests are, say, very structured, reliable, validated questionnaires, usually questionnaires that are designed to tap into a particular construct, meaning they're designed to measure a particular thing. So something like personality tests. There are a series of questions that are designed to measure or classify somebody's personality. The same with, say, intelligence or aptitude, right? Intelligence tests are a number of questions. All of them are designed to tap into a person's intelligence. Don't get me started on IQ tests. Lots of problems with those. Just, yeah, lots of problems with how even they define intelligence is it's kind of bullshit to me. But they're there. They exist. And when it comes to aptitude, we're talking about, people's ability or their skill for a particular task. So tests are all designed to measure a certain thing. Even the tests that you take in this class, the exams that you take in this class, or all of your classes, right? They're there to measure how much you have mastered the material in the class. So essentially, your aptitude in for this class, your aptitude in research methods to material, course material. Now, some of you, I'm sure, are going to complain about the exam because you didn't do as well as you would like to have, probably, or you thought it was a shitty exam. It didn't really measure what I said it was going to measure. Maybe I threw a whole bunch of questions on there that had to do with, I don't know, physics or chemistry or something. Had nothing to do with the material we learned in this class. Well, then the test is invalid because it's not measuring what I claimed it was going to measure, right? Hopefully that's not the case. But sometimes, once in a while, a bad question makes its way onto an exam. And I can, by now, been doing this a long time, have a lot of training in test development, scale development. If you checked out any of my pubs, don't. They're pretty boring stuff there. So a lot of them deal with developing scales. So usually I can identify bad questions on exams, and I just toss those out. Behavioral measures, so we can just take a look at how people are behaving, how they're acting, and we can use this as a measurement of the variable that we are interested in. A couple of issues that happen or that come up with behavioral measures, they tend to be the gold standard for some variables, particularly behavioral variables, right? So you could just think about even the elections that are coming up, right? So if I asked you if you're going to vote in the next election, I'm using a self-report technique here, right? I'm asking you a question, and you're going to say yes, probably. But what is going to be more reliable? Me asking you if you're going to vote in the election, or me actually seeing you at the polling place voting, right? So behavioral measures can certainly be the gold standard in that regard when it comes to certain variables, particularly behavioral variables. Again, if I ask you if you floss every night, yes, of course, everyone flosses every day, right? That's pretty much what everyone's going to say in a self-report, but it's going to be much more accurate measure if you really do floss for me to see you do it, which would be really kind of creepy, right? So behavioral issues or behavioral measurements are not always possible. We can't really put a camera in your bathroom or have an experimenter there making sure that you're flossing. Even so, just knowing that a camera's in there or knowing that someone's watching to see if you're going to do something we have a name for that, right? It's the experimenter effect. Just knowing that we're being watched is going to make us more likely to do the the flossing or to make us go vote. So knowing that we're being watched can obviously have an effect on how we behave, right? This is all why we all slow down while driving when we pass or when we see a cop on the road there. And then physiological measures we talked a little bit about already. Heart rate, brain activity. There's a whole bunch of different physiological measures, and the technology is getting much cheaper. So more and more smaller universities and colleges, even liberal arts colleges like SUNY Oneonta, we do have quite a bit of bio and physiological equipment. So, we can't use it now because we're in a pandemic, and nobody's allowed on campus, but that equipment's there, and it certainly was getting used. We were all kind of getting trained on it before the shit hit the fan, so to speak. Okay, so when it comes to the different approaches, even when dealing with, say, self-report type of data, and also behavioral stuff. Anytime we're making any types of measures or any type of measurements, we can take either a quantitative approach or a qualitative approach. So a quantitative approach is when we're going to measure things and express that measurement in a numeric type of way, right? So the measurement is expressed numerically, quantitatively. This is usually what happens in psychological and behavioral research, because it allows us to use statistical tests to evaluate our data. It says here to evaluate this date. That's a typo. To evaluate the data. So when we have numbers, we can run stats on those numbers. Qualitative approaches to measurement. This is where measurement is expressed either as a category or as a narrative. In order for you to use statistical tests on qualitative data, because we're not collecting any numbers here, we're collecting people's stories, or we're collecting, people's groups, or any data that we're collecting from people is nominal, meaning it's a name or it's a category. We can't do math on words like that. So in order for us to run statistical analyses on qualitative data, we would first have to do what's known as content coding. And that is horrible to do. It takes so much time, especially if you're getting long narratives from people, and if you have a lot of people. Content coding basically means you're going to go through, you'll have a predetermined list of the things that you would be interested in, or how else could we put it? I mean, maybe not even that you're interested in, but a predetermined list of words or themes that might appear in these narratives, and you're going to have to read through each one. At any time this word or this theme comes up, you're going to assign a 1 to it, right? Or 2 to this other theme, or 3 to the other theme, or 4 to the other theme. I had to do content coding for a study that is still have not published here, dealing with stereotypes. So asking people to list common stereotypes of different groups of people. And what was I doing? I was asking people to write out a sentence, right? So stereotype about a particular group, they would write it out. All people of this group do this, or they all do that. Okay, so I got that type of data, and I asked people to list like 10 stereotypes about like 6 or 8 groups or something like that. and I asked hundreds of people to do it. So there was a lot of narratives, or a lot of these sentences I had to go through and kind of categorize and say, well, these both kind of, a popular stereotype about bisexual people, for example, is that they're promiscuous, that they sleep around a lot, right? So someone might have said bisexual people are promiscuous. Another person might have said a stereotype is about bisexuals is that they're slutty, or they sleep around, or they cheat on their partner. Well, cheating, that became a whole other separate set, but just this idea of being promiscuous. Anytime I saw that, it had to get coded a certain way. Cheating, infidelity was a whole other stereotype that popped up, so on and so forth. But you can imagine, I ended up with like 40 or 50 different types of stereotype themes that came up that I then had to code for each of these participants. So it's a lot of work, but it was really kind of the only way to do it, right? The only way to really learn about what stereotypes people have is by asking them. So, but if I could avoid doing qualitative research in the future, I will do that. It was a lot of work, very time consuming. But even how we ask a question, we can measure things on scales, or we can measure them, categorically. So something like sexual orientation, traditionally it was measured qualitatively. The standard 3 that were pretty much how sexual orientation was measured for a long time, even after Kinsey. People think, after Kinsey came around, everything changed. Yeah, no, I mean, he definitely changed how we viewed sexuality and sexual orientation, but people still humans like to group people into boxes, right? Even now when we think of gender being measured on a continuum, let's say femininity or masculinity being on the opposite end, and all of us fall somewhere in between there. There's still people who want to actually carve out little boxes with labels in the in-betweens, even. And I think that's just, human nature. We like categories, and sometimes categories matter to give meaning to people, or to phenomenon, and also to give a sense of identity or belonging sometimes. As a statistician, I don't like them. I think everything is measured on a continuum. But something like sexual orientation, we said traditionally it was you were either gay, straight, or bisexual. That was it. This is a pretty antiquated way of measuring sexual orientation now, especially after Kinsey. Kinsey has a scale. And the Kinsey scale, there's 8 separate questions in there that tap in not only to people's sexual desires, but also their emotional connections or romantic connections, and not just their behaviors, but also their wants, their desires, their behaviors, romance, so on and so forth. But you can see, just as an example of measuring sexual orientation on a scale of 1 to 7, from exclusively homosexual to exclusively heterosexual, or measuring the same exact concept or variable of sexual orientation on a qualitative scale. The quantitative scale is going to give us much more information, right? So if somebody scores 5 or 6 on this scale, they might, they're not exclusively heterosexual, but that same person, if they were only given 3 options, they would likely choose straight, right? So you get more information with quantitative types of data or scales, let's say. So getting to this idea of different types or different levels of measurement here, we saw with the sexual orientation example, the gay, straight, bisexual, that would be an example of a nominal scale. So the goal here is just to classify groups, essentially just to separate groups. We're looking at the qualitative differences. What makes these different categories or these different groups, let's say, different from one another, right? Ordinal scales essentially take those categories and then put them in some type of rank order. So they're designed to classify and also to rank people. And the ranking would have some type of meaning associated with it. So, say an example of a nominal scale, I was gonna use freshmen, sophomore, junior, and seniors, but that's actually an ordinal scale when you think about it, because the rankings, which also tell us that they're separate groups, freshmen, sophomores, juniors, and seniors, they're separate groups that are there to classify people, put them into a category, but those categories actually have some separate meanings or separate rankings associated with them. They're also telling us, your year in college, essentially, right? So something even like with the classic example of ordinal scale is a race or some athletic event where somebody's coming in first place or second place or third place. The order in which people are being listed, the order in which the people are showing up, tells us something about their place in the larger whole. The problem is when it comes to especially things like races, first place and second place it's usually really, really close, right? The difference between first place and second place, these are your top athletes. The difference is usually really, really tiny. And then there's a bigger difference between the third place person, and then maybe even a bigger difference between third and fourth place. So there are no equal distances between first place, second place, third place, so on and so forth. So nominal scales are just classifying, categorizing, whatever it is we're trying to measure. Ordinal scales are classifying and describing what it is we're trying to measure, but also putting them in some type of order that gives us a little bit more information. But interval scales will essentially take an ordinal scale and make the differences between, say, first and second and third, make them equal intervals in there. So it's an equal amount of space that exists between each of these measurements. So it classifies, it rank orders categories into the same size or into the same intervals, right? The issue with an interval scale is that it has an arbitrary 0 with it or associated with it. And what does that mean? Well, it means that a 0 doesn't really mean a lack of something. So if I said on a scale of 0 to 4, how happy are you? And somebody puts a 0 on, and circles a 0. That doesn't necessarily mean there's a complete lack of happiness, 0 happiness in this person's life. When we take a look at even, say, the different temperature scales. Just because we say it's 0 degrees outside doesn't mean that there's a complete lack of temperature that exists, right? So it's kind of not a real 0 in an interval scale. A ratio scale, on the other hand, is almost exactly the same as an interval scale, except that when we say 0 on a ratio scale, we mean 0. There's none of it. So, like I said, taking a look at temperature, 0 degrees Celsius doesn't mean there's no temperature. Just 0 degrees Celsius, it's 32 degrees on the Fahrenheit scale. So that's an interval scale, something like temperature. But if you open up my wallet, which I don't have on me now, there's $0 in there, and that means there's no money in it because I'm broke, right? So that's 0 is a real 0 in that regard. However, most of the time you're just going to see these scales combined. You'll see something called an interval ratio scale, because they essentially do the same thing. And for most of the variables that we're looking at, if we needed to, if we needed a 0 to really mean a complete lack of something, then we would just use a ratio scale. Otherwise, they're kind of treated the same way. So they're often treated the same way and discussed the same way. So if you see this right here, this interval / ratio scale, just understand kind of what they're doing. Let's go back to this slide real quick. This would be, say, an example of an interval scale, right? Measuring sexual orientation here on an interval scale. This scale, believe it or not, has a particular name. It's called the Likert scale, named after the person who invented this type of scale to measure these types of conceptual variables using self-report measures. And once we get into the chapter on survey research, we'll see that some Likert scales are better than others. There's some rules or decisions rather you have to make in order to determine, should I do a 1 to 5 scale, a 1 to 7 scale, a 1 to 9 scale? Some people would argue that this really isn't an interval scale, because you don't get to choose like a 6.5 or 6.6 or 6.65, right? There's nothing in between them. A lot of people will actually argue that a scale like this, the Likert scale, is really just an ordinal scale. But we're not there yet. I'm skipping ahead. We treat it as an interval scale. That's all you need to know for now. Because when we run the statistical analyses, it acts like an interval scale. So it's all good for us. Okay, so let's say what did we cover already here? So we talked about the different types of hypothetical things that we often like to study. We talked about why those things are hard to measure, or impossible sometimes even to measure. So we have to create a conceptual definition of what exactly do we mean by these types of constructs that we're trying to study. And then once we have that conceptual definition, we have to come up with an operational definition of how exactly are we going to measure the things that we list in that conceptual definition. Then we went on to talk about the differences between quantitative variables or quantitative data and qualitative variables or qualitative data, and the different levels of measurements, the different approaches that we can use, that we can try to measure things from a nominal perspective, or using a nominal scale or an ordinal scale, or a interval / ratio scale. Most of the time, particularly when we're planning on doing statistical analyses, we're going to be using an interval ratio scale. Okay, so the next thing that we should talk about is, say we got our construct that we want to measure, we got our conceptual variable written out, got our operations, how we're going to measure these things. We decided on what level of measurement we're going to use. We're going to use some interval ratio variables, let's say. Well, now we got to talk about whether the measures that we're going to use are reliable. And what do we mean by reliable? Well, reliability refers to consistency, essentially. Whether your measure is stable or consistent, and over time is a big one, but we'll see that there's actually different types of reliability. But something that we should mention right off the bat is that there's always going to be some error in measurement. It just comes with the territory, comes with the turf. And if we were meeting in class, what I would have you do, I bring in these little paper rulers and ask everyone to just measure their index finger. Measure your index finger using this little ruler, paper ruler, and write down your result. Then we wait a little while, I lecture for a little bit more, and then say, okay, write down or take your measurement again and write it down again. And then at the end of the class, go ahead and measure your finger again and write down the measurement. And for most people, not all, but for most people, all 3 times are going to be slightly off, just a little bit off, right? So what's accounting for that? Well, I mean, we're humans and we're trying to measure things, and sometimes we're going to be just a tad off where we start our measurement, or maybe like a little bit off in terms of counting that millimeter or not counting that millimeter. Who knows? Maybe our fingernail cast the first time, it cast a little bit of a shadow, so it looked a smidge longer. Who the hell knows what causes it? It's just error. That's all it is, right? So when we talk about the observed score, what you're actually writing down after you measure your finger with that paper ruler, what measurement you got? Okay, that's your observed score. But that observed score includes 2 things. It includes your true score, which means how long your finger really is, plus the measurement error in there, right? So whatever score you're seeing is what it really is, plus some error that exists. And humans are not the only ones, right? Even computers, statistical software, sometimes, depending on how it rounds. Even in SPSS, you might get, a different result. We're talking about a couple decimals out, maybe, on a statistical test. If you perform it in SPSS or if you performed it in Excel, you might say, well, how come the decimals are off? Well, because one's rounding up, one's rounding down, or one's rounding to the 10th digit down, and the other one's to the 11th. Who knows, right? So there's always going to be some level of error. It needs to be an acceptable level of error, right? So no measure is going to be 100% accurate, especially when we're dealing with psychological constructs here, when we're dealing with people's emotions or feelings or even something like pain, physical pain. What is a 5 to you might be a 10 to me, especially when I'm sick. When I'm sick, like even with a cold, I'm horrible. I'm a big baby when it comes to that. Why? Well, because we experience pain differently, right? So part of that error is measurement error, because the scale is not going to account for all those individual differences that exist. So measurement error is going to be a fact of life. The good thing is that we can estimate the amount of error that our measurement has, and we can consider that when we are evaluating our results. So the good thing is, we know there's going to be some measurement error in there. It's okay. We have the tools to estimate what the measurement error is, what it likely is, and we're going to consider that when we analyze our results. In fact, take a look at, now you can find everywhere. Take a look at an election poll when people ask who you're going to vote for. Once we get into sampling, we'll talk about how people actually are chosen to make it into those polls, how 1,000 people in a poll can be representative of the entire voting population. If we take a look at the results of recent elections, maybe it's not. Maybe they're not representative of the entire voting population, because polls don't often match up with the actual results of those elections. But regardless, you'll see there, let's say, this candidate is ahead by 5 points. And then on the bottom, it'll say margin of error plus or minus 5 points. And people are like, well, they have a 5-point lead. They'll say, no, they have a no-point lead. It's a statistical tie, because the margin of error is 5 points. So they're ahead by 5 points, but the scale is, they estimated the potential measurement error in this poll, and it's plus or minus 5 points. So if you're within the margin of error, you're not ahead on anything. So something to keep in mind there. So when it comes to the different types of error that can occur, so we said measurement error is a fact of life, but we can estimate it. We could try to reduce it, right? We should definitely try to reduce it, but we often will refer to error as noise or statistical noise sometimes. So if you hear that term, even if I use that word, I say noise or statistical noise, I'm talking about just measurement error. That, again, it's just always going to be there. Sometimes it happens just by chance alone, just chance factors, right? There's probability associated with everything, including that you're going to have some statistical error in there, or measurement error, or noise in there. So sometimes it's just by chance, by coincidence, but some types of error can be identified. So one is observer error. Sometimes we can find out that our scale is biased, let's say, or that our scale is not measuring what we said it was supposed to measure, or in terms of we can identify that the person who was observing a particular behavior, let's say, wasn't doing it correctly, or maybe they missed a couple of participants, or maybe they missed a couple of important behaviors, or they wrote down a 3 instead of a 2, or something along those lines. Some error can be associated with changes in the participant. this is particularly true when it comes to psychological research, because think about even just our mood, right? Our mood when we wake up in the morning. I don't know if you're a morning person or an evening person, but I would teach. That's why I can't do an 8:30 class anymore. I used to teach like 2 sections of social psychology back to back, right? One at 8:30 and then one right after that. And my spies for the 8:30 class, my student evals for the 8:30 class, they were always like, yeah, he just like reads off the slides and stuff. And I'm like, I can't possibly do that. I've been teaching the same course like 2, 3, 4 times a year for the past like 15 years. Like, I don't even need slides, right? But what is it? Okay. Well, I'm a zombie at 8:30 in the morning. I'm not even awake. So I'm just like, blah, 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 blah. So staring like probably at the computer screen or something. Totally not lively at all. And that's not even just my mood. I guess that's just my level of energy or attention span or something. But, after like 2 or 3 iced coffees from Seasons, by my next class, like the spies are like, whoa, he's animated, makes jokes and all this other stuff. So much better. And that's only like within an hour and 15 minutes how much like my behavior and my mental state had changed. But you could think about other things that happen even just throughout the day, in terms of our mood, in terms of our attention span, levels of energy, happiness, our blood pressure even changes throughout the day. Our heart rates change throughout the day. Our body temperatures change throughout the day. So we're constantly changing. But when it comes to these psychological constructs in particular, yeah, we're gonna change. This is often why I think we get unfairly called like a soft science by the physicists and chemists and stuff. But again, we're measuring humans, and humans are difficult people. Right? Humans are horrible people. We're not. I love humans, but we're horrible to study. We're difficult to study. One reason is we might be really nice in one instance or one moment and be real assholes the next. And sometimes that's predictable and sometimes it's not. Another potential source of this measurement error comes from environmental changes. So maybe there's something, particularly over long periods of time. So if we want to find out, whether a test is valid over time. I had one professor, just as an example of probably number 3, environmental changes, and number 4, test characteristics. One professor in grad school for a stats class, and he's a pretty famous statistician and definitely knew his shit. And he used the same exam for 25 years of teaching, and we were all graded based on how every person who had taken that test for the past 25 years had done. The problem is that, and this was over a decade ago, probably 14 years ago when I took the class. So he was for 25 years plus, so to say, for the past 40 years, things have changed. The environment has changed, meaning he was teaching us to do things by hand that nobody does by hand anymore. It would be silly, complete waste of time to do by hand. Well, 40 years ago when he first made that test, you had to do it by hand. We didn't have access to all these statistical programs or these or at least powerful statistical type of programs. You might have had like really basic type of programs that you had to program yourself on your Commodore 64 computer or something. But the environment changed. The way we did stuff changed. Even the way that even the statistical analyses we did had changed. So his tests might have been reliable because, he was still teaching us the same outdated stuff. But it was an example of how the environment had changed, and that maybe his test wasn't really, maybe that was more an issue of validity. Maybe his test wasn't really measuring what he claimed it was measuring, because we don't really do things like that anymore. So, like I said, in 40 years, a lot of things can change in terms of, in this case, the field had changed, and the way that we conduct statistical analyses, the way we report these analyses, even the tests that we do have changed. And the test itself was asking us to do stuff by hand that we would never do by hand. So there were some characteristics of the test that were not so great, that would lead to measurement error, especially over 40 years, right? You can imagine people did better 40 years ago when doing it by hand was the only way to do it. But like by the time I took that class, I'm like, why are we doing this by hand? Like, we do all this stuff on the computer. So the test itself was outdated. So sometimes there's characteristics of exams that I make for my classes where I never purposely put in trick questions. It's like, I don't believe in them. I think I'm not out to get my students, right? Like, I want everyone to succeed. But I've also been doing this stuff for a really long time. So for me, there might be two answers to a question, and I'm like, well, yes, very clear which one is the right one. Well, that's easy for me, right? Because I have a PhD. It's a research degree. But for someone like as an undergrad in what is really just part 2 of an introduction to research class, it's not obvious. It's tricky. And it's not something like you can just Google or look in a book or something. It's something that comes from years of experience. So I forget that sometimes, right? Sometimes I have to remind myself. So if there are bad questions or something that pop up on an exam, it's usually because of that. Is that for me, they don't seem like bad questions, or they don't seem tricky. But usually a student, after talking to a student or two, I realize, okay, yeah, I should not expect students to be able to make this distinction at this level of a research class. So sometimes there's some bad tests. I try really hard to make good tests, though. Okay, so then how do we assess reliability? Well, again, there are a couple of types of reliability. So there are a couple of ways that we can assess reliability. We said earlier, reliability essentially relates to consistency. So is your test consistent? Is your measurement consistent? So one way to assess reliability that kind of makes the most intuitive sense is something known as test-retest reliability, which means that, well, kind of what the name suggests. We test you once, we wait a period of time, a certain period of time, and we test you again and compare the scores. So if a test or a measurement has good test-retest reliability, that means those two scores, how you perform on the first time, or the first measure, first time I gave you the measure, should be highly correlated to how you score or how you perform on the second time that you took the test or completed the measurement. So test-retest reliability measures the stability of scores over a certain amount of time. Now, if it's not, if you don't wait long enough, so if I give you, let's say, I give you an inventory, a scale on, say, racism, let's say, and you complete this 10 or 12 item scale, and then the next day or the next class, 2 days later, I give you the same scale, and then I say, hey, look, there's like a 90% correlation between these scores. This has really great test-retest reliability. Probably not. I didn't really wait that long, right? I waited like a day and a half, essentially. Why is that a problem? Well, because you might have remembered what you put down on the first exam, on the first test, or on the first, how you answered those questions the first time. So you want to make sure it's over a long enough period of time, because really, what else would I be able to say other than my test is stable for 2 days? You kind of want to wait a longer period of time, but you also don't want to wait too long because of all the reasons that we saw on this slide here. Is that there might be some participant changes, so you might be actually introducing new error or new measurement, potential for measurement error in there. For example, students tend to become more racially accepting or become more tolerant in general of individual differences at the end of 4 years of college than at the beginning of 4 years of college. You can take a look now in terms of the different social issues that are going on. There's lots of environmental changes happening. Black Lives Matter has been around as a movement, has been around for many years, but it's really only gained widespread acceptance recently. It was pretty much derided for a number of years of its existence. Really kind of, again, got widespread acceptance, not complete acceptance by far, but more mainstream acceptance now, because we had some really horrific events take place over the past few years dealing with race. So definitely environmental stuff has happened. So if you wait too long, you might introduce more error. If you don't wait long enough, you're not really learning much about your test, right? We also have what's known as parallel forms reliability, and this is similar to test-retest reliability, but in this case, you're basically getting two different versions of the test. So this will happen sometimes where professors will come up with different versions of an exam to help prevent cheating, right? So there'll be like a version A and a version B of an exam. That professor is going to want to make sure that those two versions have high parallel forms reliability, meaning that the scores on average, the scores on version A are highly correlated, if not close to perfectly matched with the scores on version B. Otherwise, your test is not reliable. Neither test is reliable in that sense, because they're producing different scores. They're not producing consistent scores, and that would of course be unfair to your students. Another form of assessing reliability is by looking at what's known as internal consistency. Now, this is often associated with scale development and factor analysis, but the very basic way of describing internal consistency is that your participants, if you're trying to measure the same construct using several different questions. So again, just going back to our example, if we created a racism scale, we wanted to measure people's level of racism, and we're going to ask them 10 or 12 questions that are going to tap into, racist attitudes or beliefs. If that scale has internal reliability, internal consistency, right, that means that participants should be answering the same way on each of these questions, unless your questions, some are reverse questions, right? Sometimes you'll get a scale that will ask a question but in reverse. But when we evaluate internal consistency, we reverse code everything, make sure everything's in the same direction. So if the scale has internal consistency, that means people are answering the same way on each of these items. Once in a while, you'll come across an item where it's not correlated at all with any of the other items, and you're like, damn, I thought this question was measuring racism, but clearly it's not, because it's not related to any of these other questions, right? All these other questions are correlated with one another. They're all sticking together. This one, I don't know what this one's measuring, but it's not measuring what those are measuring up there. So if you're going to create a scale that says it measures this, then all of the items on there, people should be answering in a consistent way. So if you have an item or two or three that are being answered in inconsistent ways, they're being answered very differently, you're getting very different responses than the rest of the items on your scale, you might have to change those items or just get rid of them in general. Okay, one other that we'll talk about deals with inter-rater reliability. So inter-rater reliability we use often when we're doing observational types of measurements. So inter-rater reliability measures the consistency of a measurement made by two or more observers. So again, typically used when we're doing observational research. You want more than just one person measuring a behavior, or one or more observers measuring a particular behavior, because we can interpret things in different ways. So forgive me if I gave this example already in this class, but when I first got to Oneonta, I was coming from teaching at Brooklyn College, and the population is very different, in terms of not just the socioeconomic demographics, but the type of schools that we are, urban versus rural, commuter school versus a residential college. They're both liberal arts colleges, but Brooklyn College had, masters in psych programs. We had a PhD in psych program that was housed there. So, when I came up here, I didn't know how I needed to change my teaching or my grading or my assignments. But luckily we have Dr. Charlene Christie, she was the only social psychologist up here in our department at the time. And when I taught social psych for the first time up here, and I had papers from students, I would grade them, and I didn't know if I were being too lenient or too difficult. So, I asked her if she would mind that if I took the students' names off of the papers, if I gave her, just a random sample of some of my students' papers, if she would grade some. just so I can compare my grading to her grading. What was I doing? Well, I was looking for inter-rater reliability, essentially, right? I wanted to make sure that I wasn't being too difficult or that I was being too lenient in terms of my grading. And the good news is we were pretty much right on, like exact almost, when it came to the grades that we gave. So that was definitely made me feel better about, how I was approaching teaching at my new job back then. So, okay, when we take a look at what statistical analyses that we use to determine reliability, it's almost always done using some form of correlation. And you learned about correlation in 221, but we're also going to do a quick review of correlation coming up, I believe, next week. And believe it or not, there's an entire field of statistics that is dedicated to test and scale development. It's called psychometrics. I've been trying to get a class going to try to teach this, but students don't seem very, very interested in scale development or psychometrics, even though it would be really good, look really good for you on your applications to grad programs. And it's actually kind of fun. It's not so bad. We'll do a little bit of it in this class, a little bit of scale development later on. But it's not so bad. I published a bunch of, like, 3 scales I created. So, I'd like to teach it so I don't forget that stuff. Gotta use it or lose it. Okay, so the next big thing that we are always interested in when evaluating measures, besides reliability, is validity. And when we talk about validity, we're referring to whether our measure is really measuring what we want it to, or what we say it is, right? So are we really measuring weight loss? Are we really measuring racism? Are we really measuring depression? Or are we really measuring how well students are learning the 222 material? Or are we measuring something else? There are different types of validity, and unlike reliability, there's no statistical test that we can do per se. No one type of statistical test to determine whether our test is valid. Reliability is, in my experience, much easier to determine. We could just run some correlations, so long as we know what we're supposed to be looking for, we got correlation. That's pretty good, pretty easy, right? Validity is a little bit more subjective in there, but there are different types of validity, and some of them are more subjective than others. Well, there you go. Here's starting with the first one, face validity. This is about as subjective as it gets. So when we say that something has face validity, we're saying, well, on the surface, it looks like it's measuring what it intended to measure, right? So what do we mean by that? Well, if I say that let's say exam 1 for this class, it would have face validity if I looked at the items, or if I had a colleague in the psych department, another professor in the psych department, look through my exam, and if I say, hey, could you let me know, does this look like it's a comprehensive test? Does it look like it's measuring what students should know in 222? And they flip through it and they say, yeah, that looks like what they should know in 222. That's face validity, right? So does the measure appear to measure what it intends to measure? It's a high level of subjectivity in there. And for an exam on a class, on a course where we're experts in the area, this is usually about the extent to which people or professors are going to, or most professors are going to, go when determining whether their test is valid. Content validity is whether or not the items that are in our test represent all possible items that could be on there. What do I mean by this? So let me just give an example again of our 222 test. So our first exam. If I only included items from this chapter 4, and I left out items from about APA, and I leave out items about regression, and so I told you for chapter, or for the first exam, you're going to need to know these chapters and this material, right? All of this material is going to appear on the first exam, but all the questions come from just this chapter. Well, then I do not have good content validity, right? Because where are all the questions from all the other chapters that were supposed to be on the test? You told us to study all these chapters, we learned all this material, and they're nowhere to be found. They're just here. I'm sure this has happened to you probably multiple times when you're given a test in class, and you're like, how come there was only one question on that chapter and there were like 20 questions on this one? It's probably not good. It's probably not a good test in terms of the content validity. So items that are on that exam don't represent all the possible items that could have been on the exam or should have been on the exam. And again, if you're talking about personality tests that you're developing, say you're developing a new personality scale, well, there's lots of different questions that you can ask in order to try to tap into, somebody's personality or different personality traits. But if all the items are really just asking about neuroticism or extroversion, then this wouldn't be a very valid scale in terms of content validity, because you're not asking about any of the other personality traits. So hopefully that makes sense. Criterion validity. This is a good one. If you have a scale, ultimately, scales, we want to be able to use them to be able to predict or to describe something about our participants, but also to predict behaviors or predict how their mood is going to change, or say if it's a depression scale or an anxiety scale, we would hope that scale would predict what kind of symptoms that they would have, let's say. So all of those behaviors or symptoms or actions that occur can be used as criterion by which we judge our scale. In other words, how well does this measure, how well is it related to a particular outcome, usually a behavior that reflects the same construct here. So one example that we can use in terms of criterion validity, if I have a scale that says I have not even a scale, but just the SATs, right? The SATs that most of you, I'm sure, took to get into college here. They're supposed to predict how well you are going to do in college. Essentially your GPA in college, right? So your SAT scores are supposed to predict your GPA. So in this case, the SATs, that's the measure. That's what you're going to take, right? That's the scale, let's say. A long test, painfully long test, until you take the GREs. Even worse. But the SATs, are designed to predict who's going to succeed in college or not. They don't at all, actually. They're really shitty indicators of how students will do in college, but they're used that way. So your GPA would be the criterion, right? That's what we were trying to predict with this SAT scale. And the SAT people know it, so I'm not divulging any secrets here. It has less than impressive criterion validity, the SAT score. Now, for example, when I was a crisis counselor, I would do suicide assessments. So suicide assessments, there's really, there are a couple questions that we ask, but there's really three things that we want to kind of tap into when doing a suicide assessment, and that is whether or not the person has a plan to commit suicide. So what is their plan? Essentially, how are they going to do it? When are they going to do it? So on and so forth. The second thing that we wanted to tap into is whether they had the means to commit suicide. So if someone said, "Yeah, I'm gonna shoot myself tomorrow morning," well, that's a plan for sure. Do you have a gun, right? No. Do you have access to a gun? Do you know anyone who has a gun? No. How are you going to get a gun, right? So these are all questions designed to tap into, do they have the means to do this? Well, I'm going to go buy one. How old are you? Okay, well, I'm 15. Okay, then you're not going to go buy a gun tomorrow at Walmart or something, right? So, but even so, maybe they could go buy it from a friend or off the street. Who knows what? But the third part of that assessment dealt with whether or not they had actually taken steps. Did they actually go buy the gun yet? Have they been saving money to go buy the gun? So it was three concepts. There were different items, different questions we would ask to try to answer those bigger types of questions. And that suicide assessment, just knowing those three things, are actually really predictive of who is going to attempt suicide. So clearly, if a person didn't have a plan, didn't have the means, and did not take any steps, we would consider them low risk, because research has shown that these three things are actually, pretty predictive of who is likely to attempt suicide. So in this case, attempting or committing suicide is the criterion for this type of assessment, right? That's the behavior by which we're judging this assessment or this scale. Little morbid there, but it's useful in lots of ways to examine the criterion validity of your measures, particularly if you're claiming that this measure is going to predict how well a student's going to do in college, for instance, with the SATs. It should probably do that if you're claiming that it's going to do that. Okay, concurrent validity. This is also a way to try to judge the validity of a measure. So this is how well our measure correlates with other relevant measures or other relevant outcomes. So there are a couple of things, if you take in social psych, or even in personality psych, we learned that people let's say people who are racist typically tend to also be, say, homophobic and sexist, and xenophobic. They tend to be less open to experience, less open to new experiences. They tend to be more tribalistic, right? So if I'm developing, say, a new scale on sexism, I would probably, while I'm testing this scale, include some measures of, I would include some measures of older sexism scales or other types of sexism scales, but I would likely throw in some racism scales in there as well. Definitely throw in a homophobia scale. Even my own research shows sexism and homophobia are about 0.86 correlated. Like, they're almost the same thing. Sexism and homophobia. If you're one, you're likely the other. So if my scale, people are scoring high on my sexism scale, and they're scoring high on this racism scale and high on this homophobia scale that I included, I would say that my scale has good concurrent validity. Why? Because they're scoring in such a way on my scale and on these other scales that I would expect them to score high on as well. Predictive validity. How well does your measure correlate with future outcomes? This is a lot like criterion validity. So we'll kind of treat them the same way for this class, but predictive validity might be more in terms of how well somebody is going to, or how well your scale would measure how someone will perform in the near future. So it's very similar to criterion validity. Discriminant or divergent validity. This is the opposite of concurrent validity. So this is, does our measure not correlate with some other traits or measures or behaviors that it shouldn't correlate with, right? So if I'm doing, again, my sexism scale, and if you score high on my sexism scale, I expect you to score high on the homophobia scale. That would be concurrent validity. But if you're high on the sexism scale, let's say I would expect you to score lower on, say, women's rights scale, right? And that might be a separate scale that exists out there. Or I might expect you to score lower, say if you're high in sexism, I would expect you to score low on rights for transgender individuals, let's say, right? That would be an example of divergent or discriminant validity. So if my scale is measuring what it says it's measuring, your scores, you should score the same way on relevant other scales, and you should score the opposite on scales that are different, or in ways that I would expect you to be different, or to score differently. I hope that's making sense. Let me try to come up with another example here. So let's say we have measure for depression. If I throw in if I'm trying to measure divergent or discriminant validity, and I have this measure for depression, I would probably throw in a happiness scale too. So if you're scoring high on my depression scale, I would expect you to score low on the happiness scale. That would be discriminant or divergent validity. If I threw in a anxiety scale, we know depression and anxiety tend to go together, tend to be pretty correlated. So if you score high on my depression scale and you score high on my anxiety scale, I'm going to say my scale has concurrent validity, right? You're scoring high on this scale and scoring high on a scale that I would expect you to score high on. So good for my scale, right? If you're scoring high on my depression scale, sucks for you, not good for the subject, but good for my scale if you're scoring low on a happiness measure. That would be divergent or discriminant validity. Okay, and just to wrap this lecture up, since it's almost going on 2 hours. Wow. Okay, just taking a look at the relationship between reliability and validity. So in this first bullseye here, we could see this first target. If this is the bullseye, this means we're measuring everything exactly how we want to measure it, but look at where all our measurements are. We're totally missing the mark, right? The scale is not valid because here's where our measurements are, and my scale says, nope, I'm measuring this right here. And my results are saying, nope, you're measuring something way out there. But take a look at them. They're actually pretty close together. All of those scores are clumped together. So in this case, my scale is pretty reliable. They're pretty consistent, right? I'm getting the same pattern of scores. They're just not what I say they are. They're reliable, but they're not valid. They're consistently bad, essentially, right? That's why I always made a joke when I was in graduate school. I would make plans with friends, but I would often have to cancel at the last minute, so it's really hard to be a good friend in grad school. But I said at least I'm consistently inconsistent, or I'm reliably unreliable, right? You could count on me to cancel at the last minute. So this is kind of what's going on there. We're consistently or reliably not valid. In this case here, we have an example of being neither reliable nor valid. So we're missing the bullseye. So we're not measuring what we say we're measuring. We're all over the place. And being all over the place, there's no consistency. Even though we're missing the mark, we're all over the place. So there's no reliability in the scores like there are right here. These are all consistently hitting one area. We're all over the place. So no consistency, no reliability, and they're certainly not on our bullseye. So no validity there either. This last example is where we want to be. This is where we're both valid and reliable, right? So we're all right around that bullseye. So we're measuring what we say we're measuring, and the scores are all pretty consistent, right? They're all right in there. Some measurement error. They're not all gonna fall directly on the bullseye. That's cool. That's fine. This is what we want, right? We want our scores to be hitting our target, measuring what we say that they're measuring, and we want the scores to consistently measure what we say they're measuring. All right. Whew. That was a long lecture. What are we going to do next? We're going to do a review of... Oh, I forgot I had this little thing in here. So just to wrap this up, you can be reliable. Your scale can be reliable, or your measurement can be reliable without being valid, but you can't be valid without being reliable. So we can be consistently bad or consistently unreliable or invalid, right? We can be consistently missing the bullseye, but we can't keep missing the bullseye and be consistent. That's not possible. So with that said, next lecture I'll do a quick review on descriptive and inferential statistics. So it's just going to be hopefully it'll be a quick recap of just understanding what these things do, why we use them, do a quick review of things like effect size, things like sampling, error, things like p-values, so on and so forth. But basically just a really quick review of 221 stuff before we get into the new statistical methods for 222. Okay, for real this time, I'm Audi 500. So yeah, in a bit, I'll be back.